Now it's time to check out under the microscope what's wrong with Jay's Olympia Discovery Color ID globe. Because the LEDs are not working. So we'll take the outer shell off. And to take this PCB off, all it's got is 3 Phillips screws on top of it to hold it securely. And then the PCB just comes right off, and it's got some components on the bottom of it. Got some got some capacitors under there. It's got some crystals, and it's got the infrared receiver. That's it. This part right here. So quite complex this little board is. And then the base here, we got the hub to attach the PCB in, and there's 2 terminals for the I would assume power and ground. And then right here, you can just see it. There's an IR transmitter in there. So my like I said in the last video, that all the brains in here, there's probably a power supply in here to take the 9 volts and beat it down to 5 volts or 3 volts or whatever the chip needs to run. And then the circuitry to make the infrared fire out. And we got a brushless motor here, and then there's all the stuff for the telephone stuff in here. The caller ID, and then probably got to have some voltage regulation in here and all that other good stuff. So we'll take this apart a little later and see what's inside. So now we'll go ahead and take a look at this underneath the microscope. So for you guys, I'll have picture-in-picture something happening on the tubes here. So we'll take a look at this underneath the microscope, and I'll get the recorder going. Because I don't have capture cards and all that other good stuff like the real streamers got. So here's the board underneath the microscope, and I'm at the lesser of the magnifications. We got a little cat here from the lioness. There's the blob on chip. All the various resistors going out to the LEDs. So that all looks pretty good. I don't see any weird broken solder joints. We come in a little further. 47 ohm resistors. We got a capacitor. Some crusties. Probably nothing to be concerned about. I'll take a look at the other side of the board. See what that all looks like. Capacitors all look good. There's the IR receiver. Big old blotter solder blob on there. Look at that. It's huge. So apparently, from what I understand, that this IR receiver, depending on its alignment, can greatly affect how the globe operates. And it looks like it's at an angle, which is kind of odd, because this globe has the capability of displaying messages at different colors, either red or green, along with the everyday blue. So now we'll take a look at the LEDs, see what they look like. So we got a lot of LEDs on here. See, there's 1, 2, 3, 4, 5, 6, 7, 8 LEDs, and 3 across. So there's 24 LEDs on here. So that being said, I'll have to see what color they are. Is it which one's the blue ones, and which ones are the red ones, and which ones are the green ones? And then we'll test them. See if they still work. And from what I've seen, from my perspective, is that the ones on the left-hand side may be the blue ones. And I also see some black spots. So usually blackening of an LED usually mean that it's pretty close to the end of its life. See, like this one up here looks brand new. This one here, it's got a little black. This one's got black. This one's got black. This one's got black. This one was sort of on the road to turn black. This one's got some black in it, so I would assume that these 8 here have the most hours on them. And these other sets of 8 don't have any, or hardly any hours on them. So let's power them up to see what does what, and what works and what don't work. So now I'll get a power supply, and I'll have to get some probes to power them LEDs up. So I got my little power supply here, my little LED driver, so we'll hook him up. So he's about 3 volts. So now I need some probes. So I'll use my nice meter here. This kind. So we won't be turning him on just yet, but I do want my probes. And I won't be using the stock probes. I'll be using my probes that I got from Rossmann Repair. He's got these nice needle point to stab all this tiny surface mount stuff. I'll do some testing of the LEDs to see if they're any good or bad, and see what color is what. So we'll start anywhere around here. So that's a blue one. That's a blue one. See how dim it is? You can tell that's got a lot of hours on it. That's a real dim one. There's a red one. So the blue ones work. Apparently the ones that got a lot of black in them, they're really at the end of the road. So we will definitely be replacing them. But we got to find the cause of why they're not getting power. So we'll go to the next row here. And we already know that the middle row is red. So that's red. That's red. That's red. That works. That works. That works. That works. That works. Whoops. Turn the voltage down a little bit here. So that's a green one. So I'll have to fix that green one. Okay. So we know the blue ones are tired, and I blew up a green one. So we'll have to fix that. So we know that that works. So that's a good sign. We got some tired LEDs, which is not a problem because this thing, I think the story is this thing's been run for almost 20 years straight. So not to be uncommon for the LEDs to be worn out. So now we'll take a look at the junction where the two boards meet to see what the story is with that. There's your problem. All the solder joints where the two boards meet are all broken. Every single one of them. Look at that. So that's just from the flexing of the board, probably from spinning all these years. And would give you the indication that if you were to hit it, that sometimes it might start working again or something like that. So that's the culprit. It's amazing that the thing even worked. Amazing. So that's nothing more than just a reflow. Of course, I'll take all that crappy lead-free. That's probably about the beginning of when the lead-free really started taking off, is this era of electronics. So everything else looks good on here. So you can tell all that was all hand just soldered. Look at, they're all crooked and mismatched and everything like that. So you can tell it was definitely a hand job. So that's good. At least it's not catastrophic. I mean, catastrophic, because if that was bad right there, that would have been the end of it. Chip on blob on chip. So a little reflow work, a little resoldering of the right angle joint in here, and we'll get some LEDs in here, and definitely all the blue ones will be replaced, and I'll have to replace that green one that I blew up, which is kind of odd because usually green LEDs are sometimes a little bit more tolerant of 3 volts. So we'll fix that. That's not a problem. And definitely by eye, when you look at this, now I got pretty good eyes, and I can't even see that them solder joints are broke. I mean, it's just impossible to see it. And you can't even, I mean, I got a small little magnifying glass here, and yeah, you can see the black spot on the LEDs, but when you look over at the red ones and the green ones, you also see a black spot. But that's the way they're made. A little different construction. And then when you look on the right angle joint, I mean, yeah, you can't even tell. I mean, you can sort of see it, but offhand, see, like me right now, I know that they're broke, so I can sort of tell myself, yeah, they're broke. But a casual user would never know. And I know that Jay looked at this with his visor, but I don't know what kind of magnification that it has, whether he spotted that or not. I would assume he didn't even really look, I mean, close enough to see if they were broke or not, and he would have never even known about the black spot on the blue LEDs. So that's good. Simple fixes. I mean, just broken solder joints to completely destroy this thing, or to the point where it has, normal people would have thrown it in the garbage. Which I wonder how many actually did go in the garbage just because of that. I mean, once the pixels start going out, I mean, yeah, maybe 1 or 2 pixels, most people would live with it, but once it starts getting really knackered, people are say, well, that's the end of it, and they would toss it out. So that's a simple fix. So we'll get some new blue LEDs, and we'll get a couple of green ones, and we'll fix that up because that looks pretty awful. So let's take a look at the base of this thing because I'm sort of curious to see what's in here, and we'll check it out. So we'll get a screwdriver here. Of course, I'll have to have a long barrel. I don't think it won't reach in there. It's too deep. So some of the instructions or destructions say, actually not, it's not in the destructions on how to take this apart, but some suggest if you never had the globe off that you do take the base off first and then unlock the tabs, but you know. So we'll take that off. Should come off fairly easy. Make sure there's no goodies coming out other than some broken plastic bits. So we'll put that off to the side. And here's what's inside. So we got the switches here. We can just move them off to the side. And here's the inside. So we got all the electronics for the telephone, and probably the power supply, boost converters for the electronics in the arm, and there's two little wires right there. Probably can't see them. I'll have to put them under the microscope, but very, very fine wires. And they're connected to the motor, so I definitely would not be taking this board out, because you would have to unsolder them wires, and if it's not broke, don't fuck with it. So there's some components. Definitely there's some components on the underside of this thing, and this is a brushless motor, and it has a this right here, this hub. This is what provides the power to the arm. So as this is spinning, it's one of them, I don't know what you would call it, like kind of like I think a transformer, kind of like an induction transformer that sends power from a hub it sends power through a hub, so that you can have power coming up through the shaft, because otherwise, if this was a brushed system, this would have been long dead a long time ago. If he ran this for 20 years straight, this hub would have been dead by now. So here's that little safety switch that he was talking about when he took the globe off. That's the safety switch, so you can't run it without the globe. Not that you cannot bypass it or anything like that. So that's pretty cool. So we'll take a little gander at it under the microscope here to see the wires and stuff like that, if it goes up that high. Oh yeah. So we'll hit the record button here. Recording. So there's that safety switch. You can definitely tell that it was incorporated with the latch. So this is what hooks onto the plastic tangs on the globe. So there's the switch. You know, then it's got its own little wires coming out here. You know, and it's all surface mount on here. There's the mode buttons. You know, tell they were hand soldered. Another blob on chip there. We've got some hot glue snot. There's them two little fine wires. That send power to the motor or to the hub. So these are probably some transistors or some MOSFETs or something like that. So that definitely sends power to this thing. The infrared transmitters. So everything looks good in here. For something that's been in service for 20 years, don't look bad. So really the only failure parts on this thing would be if the motor went bad. It is a brushless motor. You know, sometimes the windings can you know, wear out over time, or the bearings will wear out over time. But this spins very freely, so that's in good condition. You know, and at any time, any of these little transistors or this chip can go bad or something like that. But I think they used fairly good quality components in here, because this thing has been running for decades now, and it still has the potential of going for a few more. So, like I said, there's actually 2 infrared transmitters in here. This one right here, this detects if the arm is spinning. So that's the only way this thing will function, is that the electronics in here must detect that the arm is spinning. So that one that's furthest away from the motor hub, and there's the right there is the infrared receiver. So if you were to, I don't know, oh yeah, you can see it. If I put that right in the center, that's the actual receiver for the globe to detect if it's spinning. Because otherwise, if it's not spinning or spinning fast enough, it will not tell the other infrared transmitter to go ahead and start doing its thing. So that's the This one is the detector for the arm. See if it's spinning. This one's the low battery LED. So when you see this on, it means that the batteries inside are dead. And it is 3 AAA batteries and stuff like that. So that's where the 3 AAAs. And the only reason why this thing has a backup system in it is this thing is capable of, you know, putting. You can put little personal messages on here. You can go through the menus and type in personal messages and stuff like that. And to keep the time alive in case you don't have this hooked up to the telephone system. So every time the phone rings, and depending on the phone service that you got, it will send a signal so it can automatically correct the time. But if that's not hooked up, or you're not, you know, subscribed to whatever the caller ID system is, then it won't work. So then you rely on the old-fashioned way of having a manually setting the clock. So having the clock run and having personal messages that you can put in to the globe here is only kept alive by the backup memory power. So if the power goes out, this loses power, and there's no backup power, then all the messages and the time are gone. Then you have to reset it and re-input the time in your messages if you choose. Otherwise, it's just the caller ID and the default time comes back up. So it will always keep the caller IDs no matter what. So I do know that he has that all the 54 caller ID slots are full, and most of the numbers are from his wife, and probably XJayKay18s and stuff like that, and whatever numbers. So when I do have this up and running again, I will be blurring out that information and stuff like that. But I will put the thing into demo mode to just to show you, and after that we'll see what happens with this thing. So we'll go ahead and we'll put this back together so we don't lose any parts in this thing, because we don't want to be losing parts on him, because, you know, it's not mine. So I do think this thing is very cool, and I can see the little war scar when his Wittens knocked this thing on the floor while it was running. And he did tell me that after a spell, that every once in a while he would see that the different colors would come up. Well, red actually came up. So he says every once in a while he would look at the globe, and that the red, for whatever reason, and it's undocumented of why the different colors come up. So from what I understand and what I looked up, it's supposed to, every once in a while, for whatever reason, to display messages in different colors. And maybe when it fell on the floor, and then over time, maybe that little infrared receiver on there got tweaked just a little bit, and then maybe every once in a while, when the stars align and there's high tide and all that other stuff, it would display a message in red. So that was pretty cool to hear about, read about. So that's what's in the base of this thing. This thing is actually built pretty well for what it is. I mean, if they were to build this today, it'd probably be a piece of shit. You know, it probably wouldn't last more than 3 or 4 years. I mean, to know that this thing has been running for, you know, almost 2 decades. Because he says he got this thing in 2003 or 2004 or something like that, and it was still running until he decided to take it out of service. That's a pretty good run for probably something that in the laboratory was only supposed to, you know, be in service for, you know, probably 7 years, and that's about it. So I'll be going on the interwebs, and I will be ordering some blue LEDs, and I'll have to get a green LED for the one that I blew up. Oops. And then we'll tackle this bad soldering, all this cracked solder joints in the right angle here. So I kind of had some suspicions that, you know, it had to be broken solder joints, and, you know, seeing pictures of this and on the webs and stuff like that, and just having Jay describe to everyone, and then he had a video on it when he kind of whacked it and it totally went out. That's probably why he whacked it just hard enough to get all the solder joints to separate, and then it lost complete connection, and then when he whacked it again, kind of jolted everything back. So not a problem. It can be fixed. Of course, it's hard to fix stuff like this when you can't see it, you know, with, you know, your eyes or a visor or stuff like that. So having a nice toy like this comes in handy, you know. So this thing was one of them, you know, impulse buys that, you know, I consider this as a tool, and I don't have problems buying tools, and, you know, this is something that I don't use every day, but when you do need it, it's flippin' handy. And yeah, when you look this up online, it's a lot of money. I mean, this thing was pretty much, I think it was $800 or $900. So this is an Microscope, and it's the double arm trinocular. There's 2 different trinocular heads on this one. There's one that this port here is open full time, so you can always have a camera on it. And then there's other heads that looks just like this, but there's a lever that you got to flip to access the camera port. Problem is, you lose one of your eyepieces, so you're only, you know, one eye in it, which kind of sucks. So I got the one with the full-time trinocular and the full-time eyepieces, because what you see on the screen that I'm recording, it's nothing what I see looking down the barrels. I mean, it's just a completely different world. And on top of that, you're getting kind of a cropped image where I get a little bit more real estate looking down the eyepieces. So, and of course, you got to buy it all individually. You got to buy the microscope separately, and then you got to buy the ring light, and then the camera. And sometimes you get the microscope and the ring light in a package, sometimes, but not always. So you gotta sort of shop around. And then the camera came from AliExpress. So this little guy here, he was about, I think when I bought it a few years ago, I think it was almost $400. So a lot of money sitting here, but when you need one, and you don't have a problem paying the money for it, because the philosophy is pay once, cry once. So there you go. So now it's a tool. When you don't need it, you put it away safely. When you need it, it comes in real handy. So that's it for this video. Stay tuned for the next video when we replace the LEDs, fix up the solder joints, and see if it works. So thanks for watching. We'll see you on the next video. Bye-bye.